Yeah, hi everyone. In this session, we will discuss about page replacement algorithms. So in the previous classes, we have seen what is a paging and what is segmentation. Okay, and how about a page table and what about segment table? All those things we have seen. Okay, so now let's discuss about page replacement algorithms. Okay, so the name itself, it is very clear that page replacement algorithms means we are going to replace the pages. We are going to replace the pages. So where exactly we are going to replace the pages? So we'll see where exactly we are going to replace the pages. So we know that a process is divided into number of pages. Yes or no? Let us suppose these are the pages. Page 0, page 1, page 2, page 3, page 4, page 5. Okay. So a process is divided into number of pages. Similarly, we know that the main memory is split into number of frames. Frame 0, frame 1, 2, 3, 4, 5, like that. So what happens? So the main memory is divided into number of frames, okay, and the process is divided into number of pages, and the size of each page is equal, and the size of each frame is also the same, and the size of page and frame are one and the same. Why? Because we have to fit this page inside this frame. Okay. So suppose what the R is telling is, suppose if CPU is this frame, whatever the page we keep inside this frame, no, that particular page will be executed by the CPU one by one. Suppose CPU is searching for, let us suppose here we have 0, 1, 2, 3, 4, 5 pages were there. Suppose if CPU is searching for a data which is not available in the main memory. If CPU is searching for a data while execution, if CPU requires any data, if the data is not available in the main memory, then we call it as miss. Whatever the data the CPU is searching for, if the data is available in the main memory, we call it as hit. Okay. So when miss takes place, whatever the data the CPU wants, if the data is not available in the main memory, what it has to do is, it has to bring the data from the secondary memory. It has to bring that data from the secondary memory. Okay. From secondary memory it has to be brought into the main memory. Already existing data, okay, should be sent to the secondary memory. So here the problem is, which data is to be replaced with the new data. Okay. If suppose if there are 3 persons sitting in a seat, okay, if the new person comes, okay, definitely he has to get placed in this seat. So means out of these 3, one has to get up. Who has to get up? There are number of criteria. Sometimes out of those 3 people, the people who is very young, he will get up. Sometimes no. So there might be some situation where, okay, let the kids sit, and the person who is older, he may give place for the new person, like that. Okay. So what strategies we are going to follow? Page replacement algorithms. For that we have different page replacement algorithms. Okay, these page replacement algorithms are nothing but we are giving way. Okay, so a new page is to be substituted in place of the existing one, which is to be replaced. For that we have 3 different algorithms. They are nothing but FIFO, first in first out page replacement algorithm, LRU, least recently used page replacement algorithm, last but not least is optimal page replacement algorithm. We will see these one by one. Okay. Suppose if you see here, first in first out, let us consider the strings. These are the sample reference strings, let us suppose. Okay, these are the reference strings. Total 15 were there. Let us suppose the size, the number of frames are 3. Okay, in a main memory, let us assume that the number of frames are 3. So that's why 1, 2, 3, 1, 2, 3, 1, 2, 3, like that we have kept, right? Okay, so initially this is taken initially. So initially it will be empty. Okay, initially it is empty. So now we are going to place 7 here. Okay, we are going to insert 7. So 7 is inserted here. Okay, previously it is empty. Now there is some change. So means some page fault has occurred. Here there is a concept like page fault. Page fault. Page fault. What is page fault? If CPU is searching for a particular page and if that page is not available in the main memory, then we call it as a page fault. Let us suppose this is main memory and this main memory is split into 3 frames because we have assumed 3 frames. 1, 2, 3, right? 1, 2, 3, 1, 2, 3, like that. So we have assumed 3 frames. Initially the main memory is empty. Okay, now the CPU is searching for page 7. It is not available. So we have kept page 7. Okay, so one page fault has occurred. We have represented it with PF, page fault 1. Okay, next, it is searching for 0. So 0 is not available. So we will insert 0. 7, 0. Page fault 2. Here 1. So 1 is to be inserted. 7, 0, 1. So page fault 3. Up to here, it is very clear, I think. Okay. So this is frame 1. Right? Frame 1. This one. This is frame 2. Frame 3. Right? First we have inserted frame 1. Next we have inserted frame 2. Next frame 3. Right? Okay. So now 2 is to be inserted because CPU wants page number 2. Okay. CPU wants this page 2. CPU wants page 2. But unfortunately page 2 is not available in the main memory. So what happens? We have to bring page 2 into the main memory and one page from the main memory should be removed. It should be sent to the secondary memory. Which one to be sent? Here we are following first in, first out. So the page which was inserted first, it should be removed. So first frame 1 is inserted. Frame 1 first, next frame 2, next frame 3. So frame 1 is to be replaced. So 7 is to be removed and 2 should be placed here. 2, 0, 1. So page fault 4. So first frame we have replaced. Next 0. Okay, CPU wants 0. 0 is already there. So the same 2, 0, 1. So we call it as hit. Why? Because hit means you know. So whatever the page the CPU is searching for, if that page is available in the main memory, we call it as hit. So this is hit. Okay. Right. Next 3. So CPU wants page 3, but unfortunately page 3 is not available in the main memory. So we have to place or we have to insert page 3 inside the main memory. So one should be removed. So just now we have replaced in frame 1. Now frame 2. So 2 as this. Frame 2 is 0. 0 should be replaced. So page fault 5. Okay. Next frame 3. Next 0. 0 is not available in the main memory. So 0 should be inserted. So 2, 3, 0. Why? Because so frame 1 here we have inserted. Here frame 2. Here frame 3. So page fault 6. Now it is searching for 4. 4 is not available. Again 4 should be inserted. Again frame 1. 4, 3, 0. Page fault 7. Okay. So now again 2. 2 is also not available in the main memory. So again we have to replace 2. So here frame 1 no. So now we have to replace the frame 2. So 4 as it is. 2 here 0. Page fault 8. Okay. Next we have to insert 3. Page 3. So it should be replaced here in frame 3. 4, 2, 3. Page fault 9. Next 0. So frame 1, frame 2, frame 3. Frame 1, frame 2, frame 3. Frame 1, frame 2, frame 3. Next frame 1, frame 2, frame 3. Again frame 1. In frame 1 we have to place 0. 0, 2, 3. Page fault 10. So now 3. 3 is already available in the main memory. So no problem, it is hit. So the same 0, 2, 3 will write. So this is hit. Okay. Then frame 0, frame 1 more, next frame 2. So we are searching for 1. 1 is not available. So 0, 1, 3. This is 3. Okay. This is page fault 11. Page fault 11. Okay. Next 2 should be placed. So 0, 1, 2. Page fault 12. Okay. Page fault 11. This is page fault 12. Next we are searching for 0. 0 is already there. 0, 1, 2. This is hit. So total number of hits. Number of hits 3. Hit 1, hit 2, hit 3. Okay. So hit ratio is total number of hits 3. Total number of reference strings are 15 in number. 15 into 100. So we get 20%. 20% is the hit ratio. Okay. Coming to the fault ratio. So total number of page faults. Total number of page faults are PF1, PF2, PF3 and so on to PF12. 12 page faults. Okay. So page faults ratio equal to 12 by total number of page faults are 12. Total number of reference strings are 15 into 100. So 15, 8, 720. So it is 80%. Okay. So those are the number of page faults. Number of page faults are 12 and the number of hits are 3. Hit ratio is 20. Okay. And page fault ratio is 80%. So see here. What we have done here. First what we have done is, first we have taken initially the main memory is empty. Okay. Initially the main memory is empty. Okay. So now what we have done here is, first we have inserted, so first it is searching for 7. 7 is not available. So simply we will insert 7. Okay. So initially it is empty now. Means if the CPU is searching for 7, it is not available. So 7 is inserted. Okay. So it is page fault 1. Next it is searching for 0. So only 7 is there. 0 is not there. So 0 is brought into the main memory. So page fault 2. Next it is searching for 1. It wants page 1. CPU wants page 1. So page 1 is not there. Only 7 and 0 is there. So page 1 is brought into the main memory. So page fault 3. Now it is searching for 2. Page 2. Page 2 is not there. 701 is there. And the main memory is filled. So in order to bring 2 inside the main memory, what we have to do is, we have to remove 1. Which one is to be removed? Here we are following first in, first out. So this is frame 1, frame 2, frame 3. So first we have inserted frame 1. So that's why we have removed 7. Okay, in the next case, okay, we have removed 7 and we have placed 2, 2, 0, 1. So here it is searching for 0. 0 is already there. So we have written the same, 2, 0, 1. No page fault. Here hit. Okay. Next, if you see here, it is searching for 3. 3 is not available. So we have to bring 3 into the main memory. So which is to be removed? So frame 1 is replaced. Now frame 2. So that is 0. 0 should be replaced with 3. Like that we have done. Frame 1, frame 2, frame 3. Next frame 1, frame 2, frame 3. So for your convenience we have explained like that. So this is the way how we perform first in first out page replacement algorithm. So finally we got total number of hits are 3, total number of page faults are 12. So hit ratio, total number of hits by number of hits by total number of reference strings, they are 15. 3 by 15 into 100, we got 20%. Similarly, page faults, we got 12. So the ratio, page fault ratio is nothing but number of page faults by total number of reference strings. 12 by 15 into 100, we got 80%, right? So with this, we'll wind up this first in first out page replacement algorithm. Okay, right. Next, we will go for least recently used. Next, we will go for least recently used. Okay. So here also the same. Consider the page reference strings. These are the reference strings. Here also we will assume that the number of frames are 3. Okay. So in the previous case, in the previous algorithm, we have used first in first out, means the page or the page which was inserted first into the main memory, it should be removed first. Okay, right. Here it is least recently used. Recently used means you know. Okay, recently what you have done, recently what movie you have watched means what is your last movie. Okay, so what are your last 2 movies you will tell. Okay, yesterday you have watched one movie, that is your recent movie. Before the day before yesterday you might have watched another movie, that is your least 2 recent. Okay, before that, okay, the day before yesterday you might have watched one more movie. Okay, that is your last 3 movies. So yesterday, before day. Okay, so out of these 3, least recently used is the first one. Suppose today is, let us suppose today is 4th. Today is 4th. 3rd, you might have watched one movie. 2nd, you might have watched another movie. 1st, you might have watched another movie. So what are your 3 recent movies? The movie which you have watched on 3rd, on 2nd, on 1st. Out of these 3, what is your recent movie? The movie which you have watched on 3rd. Okay. So least recently used means the movie which you have watched on 1st. If you have to remove one, you have to remove the movie which you have watched on 1st. Okay, because today is 4th, let us suppose. 4th, recent movie is 3rd, before that 2nd, before that 1st. So that one you have to remove. Like that, you have to approach. Here also the same. Let us suppose initially it is empty. Initially it is empty. Okay. So now the CPU is searching for 7. Okay, 7 is not available here. So we will insert 7. So page fault has occurred. Page fault 1. Because 7 is not there now, so we have inserted 7. So next it is searching for 0. But 0 is not there, only 7 is there. So we are inserting 0 also. 7, 0. So page fault 2. Next it is searching for 1. But 1 is not there, only 7 and 0 are there. So we are inserting 7, 0, 1. So page fault 3. Now comes our technique, least recently used technique will come into act. So 2 is to be replaced. Okay. So which is to be removed? So recently 1 is there, so 1 should be there. Before that we have 0, 0 should be there. Okay. Least recently used is 7 out of these 3. Out of 7, 0, 1, recently used is 1. Before that there is 0. Least recently used is 7. So we have to remove 7. That's why we have to replace 2. So page fault 4. Okay. Next we have 0. 0 is already there. 0 is already there. So we will write the same. 2, 0, 1. So it is hit. Okay. Next we have 3. 3 is to be replaced. So recently used is 0. Before that we have 2. So in place of 1 we have to replace 3. So page fault 5. Next 0. Hit. 0 is already there now. So 2, 0, 3. It is again hit. So next we have to insert 4. So recently used is 0. 0 should be there. Before that we have 3. 3 should be there. So 2 is the least recently used. We have to replace that with 4. Okay. So this is page fault 6. Next we have 2. Okay, 2 should be inserted. So this is recently used 4. Before that we have 0. So least recently used is 3. So in place of 3 we have to place 2. So page fault 7. Okay. Next we have 3. 3 is to be inserted. Recently used is 2. 2 as it is. Okay, before that we have 4. Okay, least recently used is 0. In place of 0 we will place 3. So page fault 8. So we have again 0. 0 is to be replaced. Recently used is 3 and 2. In place of 4 we will keep 0. So page fault 9. Next we have 3. 3 is already there. So 0, 3, 2 and this is hit. Next, so we have to insert 1. So 1 is not available. So we have to remove 1, remove which is least recently used. So 3 is recently used. Before that we have 0. So least recently used is 2. So in place of 2 we have to place 1. So this is page fault 10. Next we have to place 2. So recently used is 1. Before that we have 3. So least recently used is 2. So page fault 11. Next 0 to be inserted. So recently used is 2. Before that we have 1. In place of 3 we have to replace with 0. So page fault 12. So here also we got 12 page faults. So number of hits are 3. 1, 2, 3. See here 1, 2, 3. 3 hits. Okay. Similarly, hit ratio. Hit ratio is number of hits 3 by total number of reference strings 15 into 100. So here we will get 20%. Similarly, number of page faults. Number of page faults are 12. Okay. So page faults ratio equal to total number of page faults by total number of reference strings are 15 into 100. So you will get 80%. Okay, so this is about least recently used. Okay, so with this we will wind up the least recently used topic. Okay, next we will go for the last method. It is nothing but optimal page replacement algorithm. It is nothing but optimal page replacement algorithm. So here also, as usual, what we do is, so initially let us suppose the main memory is empty. Okay, let us assume, and the number of frames are 3 in number. Okay. Sometimes now in the question they will clearly give you, consider the following reference strings. Like that they will give you some set of reference strings. And they will ask you, assume that the number of frames are 4. Means you have to take 4. Here we have taken 3 now. 1, 2, 3. You have to take 4. Okay. You should keep on inserting. You should keep on using 4 frames. Okay. Right. So now, initially it is searching for 7. 7 is not available. So we have kept 7 inside the main memory. So it is page fault 1. Next, it is searching for 0. 0 is not here. So again we have to bring 0, 7, 0, page fault 2. Next, it is searching for 1. 1 is not available here. So we have to bring 1. So 7, 0, 1. Up to here it is very clear. everything is same. 7, 7, 0, 7, 0, 1. Now optimal page replacement algorithm is nothing but here what we have to do is, suppose if you want to insert 2 in the next step, the CPU is searching for page 2. Page 2 is not available in the main memory. So 2 is to be brought into the main memory. Which is to be replaced? We have to identify which we are going to use in the near future. The page which we are going to use in the near future, we have to keep that inside the main memory. See, 7. So in the near future, we are 701. In the near future, we are using 0. Okay. 0 we are using. Okay. 1 we are using. Out of these 3, 0 and 1 we are using in the near future. 7 we are not using. That's why we will replace 7 with 2. Okay. Right. So now 2 we will write 2, 0, 1. Page 1, 4. Next 0. 0 is already there. So no problem. So it is hit. It is hit. Next 3. We have to the CPU is searching for 3. 3 is not there inside the main memory. So what we have to do? We have to replace. We have to place 3 inside the main memory. Okay. So which is to be removed? Out of 201, which is used in the near future, 0 is used here, 2 is used here, 1 is used so far. So in the near future we are using 0 and 2. So 0 and 2 we will keep. Okay. 2 and 0 we will keep. In place of 1 we will replace it with 3. So page 5 has occurred. Next we have 0. 0 is already there. 2, 0, 3. So again hit. Next 4. 4 is not available inside the main memory. So what we have to do? We have to insert 4 inside the main memory in place of any one of these 3. Okay. So in the near future what we are using? So we are using 2. So that's why we will keep 2. We are using 3 also. We will keep 3. 0 is also used. But first 2 and 3 are used first. Before 0, 2 and 3 are being used. So that's why we will keep 2 and 3. And we will replace 4 in place of 0. So this is page 6. Okay. Next 2. 2 is already there. So 2, 4, 3. So it is hit. Next 3. 3 is already there. 2, 4, 3. Hit. So next 0. 0 is not available in the main memory. So what we have to do? So if you want to bring 0 into the main memory, so which is to be removed? So 3 is used in the near future. Okay. 3 is used here. Next, out of 2 and 4, 2 is used. So 2 is used. So 4 is not used. So that's why we have to replace 4 with 0. So this is page 7. So this is page 7. Okay. Next, 3. 3 is already there. So 2, 0, 3. So it is hit. Okay. Next, 1 is to be inserted. So what we are using in the near future? So in the near future we are using 2. So 2 we will keep as it is. In the near future we are using 0 also. 0 will be kept. So 3 is not used. That's why we will replace 3 with 1. So this is page 8. So here 2 is already there. So 2, 0, 1. It is hit. So again this is 0. So 2, 0, 1. So this is also hit. Okay. So this is the way how we calculate. Okay, in optimal page replacement algorithm. In optimal page replacement algorithm, what we have done? First we have inserted 7. Next 7, 0, 7, 0, 1. Up to here it is very clear. So from here, if you want to insert 2, what we have done? So in the near future, what we are using? So out of the 701 in the near future, 0 is already there. So 0 we have kept. Next we have used 1. 1 we have kept. 7 we have not used. That's why we have replaced 7 with 2. 2, 0, 1. 0 is already there. So it is hit. So here 3. 3 is to be replaced. In the near future what we have used? So 0 is used. Okay. Next 2 is used. So that's why 0 and 2 we have kept, and in place of 1 now we kept 3. Like that we have done this. Okay. So here number of hits. How many hits we have? Hit 1, hit 2, hit 3, hit 4, hit 5, hit 6, hit 7. 7 hits were there. So number of hits were 7. So hit ratio is, so what is hit ratio? So number of hits are 7. So total number of reference strings. Reference strings are nothing but once again these are the reference strings. So they are 15 into 100. So we will get, so 5460. Approximately we will get 47%. Approximately, not exactly, approximately. Okay, we will get 47% around. Okay, so similarly here, so number of page faults we have seen. Number of page faults are 8. So 8 page faults are there. So if you want to calculate page fault ratio, so there will be a total number of page faults are 8 by 15 into 100. So number of page faults are 8. Total number of reference strings are 15. So we will get around 53% we will get. So this is the way how we calculate optimum page replacement algorithm. Okay. So with this we will wind up the page replacement algorithms. Okay. Thank you.